So in review question 1 for the Physics 115 final, zoom in here to the question. Okay, so we've got a Physics 115 student wants to climb Mount Si, a Mailbox Peak out of I-90 on the same day. It's a pretty tough feat. So Mount Si has an elevation gain of 31,050 feet, and Mailbox Peak has an elevation gain of 4,000 feet. The student has a mass 65 kilograms, and in descending, the student uses 40% of the energy used to ascend each peak. How many PB&J sandwiches, 250 calories each, food calories, would the student need to fuel this activity? Assume human efficiency of 0.25. Okay, and we have the feet to meter conversion here. Okay, so this is an human energy sort of a conservation or conversion question, where the person is going to consume some food and then convert those that chemical energy contained in the food to the gravitational potential energy of the person Earth system, in addition to expelling a large amount of thermal energy by, of course, sort of raising the body temperature and expelling that heat to the environment. So let's first figure out, so in a sense, the person is changing their height above the Earth, so that's the key. In a sense, in order to do that, they must sort of convert their internal energy, because they're raising the energy of the system of themselves on the Earth. So this question, in a sense, is related to sort of thinking that the delta U gravity is mg delta h, or mgh, or mg delta y. So the person in climbing the two peaks will climb a total, so their delta y in this particular case will be 4,000 plus 3,150 feet, so that's 7,150 feet. And if we multiply that by 0.305 meters per foot, we end up with a change in elevation of 2181 meters. Okay, so that's the total elevation gained for this person in these two hikes. So what we're told though is that the person uses 40% of the energy in the descent that they use in the ascending each peak. So our delta U, we could think of that the delta U is going to be that mg delta y plus then 40%, or 0.4 of mg delta y. So the person, the delta U is really 1.4 times mg delta y. So that's what the amount of energy, the change in sort of mechanical energy that's going to be involved in this problem. So if we have the mass is, so I'm not sure enough room left here, 1.4 times 65 kilograms, 9.8 meters per second squared, times the change in the height here of 2181 meters, and that gives a total change in potential energy of 1.95 by 10 to the 6 joules. Okay. So a large amount of energy, and the person's only doing this at 25% efficiency. So the total energy total that the person basically has to convert from their internal, or basically from consuming food or from their internal stores, it's going to be 4 times this amount. So that's the actual change, but in order to get this change in potential, there has to be the body has to basically use 4 times in order to get that, because it's only 25% efficient. So energy total is 4 times this particular value, 6 joules, and that gives us 7.8 by 10 to the 6, 7.8 million joules, and that's the total energy that the person will need to consume if we're going to fuel this entire activity of PB&J sandwiches. So we want to figure out how many. We're told that we're given the energy. Now we've got two options here. We can convert 250 calories to joules, or we can figure out how many calories are in the 7.8 by 10 to the 6, and that's sort of what I'll do here. So number of calories, or energy. Let me see. I'll write it as energy total in units of calories. To 7.8 by 10 to the 6 joules divided by 4190 joules per calorie, and that's a big food calorie, and that gives us 1860 calories, and that's probably maybe a little on the low end. Climbing both of these peaks would definitely get you very close to burning almost 2,000 calories, if not even a little more. But it seems reasonable. If maybe I would probably maybe slightly on the small side, but it's pretty close to what you might burn on a hike, 2 different hikes. So we have 1860 calories. We've got 250 calories each. So the number of sandwiches going to be basically 1860 calories divided by 250 calories per sandwich. So that gives you about 7.5 sandwiches. So I'm sure the person will be quite tired of eating PB&J sandwiches at the end of the day, but there's quite a lot of energy in each one. So 1860 calories could be fueled by consuming 7.4 sandwiches. So in a sense, only 25% of this energy is going into sort of the change in potential, and the other 25% into sort of changing the person's mechanical energy with the person or system, and the other 75% is dissipated to the environment in the form of thermal energy. So this gives you choice C as the correct answer. See that clearly.